Hello, everyone. Today we will take an investigation about the machine learning and take the first steps of the program. First of all, we what is machine learning? We need to understand machine learning is based on the data structure. The data is are also produced and store. Sometimes we just think data is a discrete value, but the process to produce and store is continuous. Data present some facilities in science or sensor networks or people to talk about some materials in science or graphics or weather measurements on mobile phones and some social networks. They got a statistic to summarize in the structure. So data is not random. So because they contain the structure with the outcomes to predict the outcomes, and we can understand from the data we collected. And so data also is hard to decide the algorithms to look like a task. Why? Because it's hard to get the same structure. So we cannot compare to or say or sort anything. For example, to classify the spam feature, so we need to take the collection of email messages that's also have label and by spam or not spam. So here's some features of data is store and is continuous, it's random and not random, and difficult to decide as task. To talk about data mining. What's the data mining? Data mining maybe could be understood like an application that we can use use machine to collect to classify the data to make the data. It's called data mining. That's on an applications data mine. There are many kinds of application to mine, to collect the data. Look like websites or some application also in statistics. So the main definitions in machine learning. Machine learning is the program on using the computer science to construct the model, to maybe predict the data or performs show the performance of the output. Machine learning, what's the machine learning counts on? So machine learning is based on some theories, statistics, or numerical algorithms, computer science. Sometimes we how to use mathematics to construct the model to construct relate to computer science. To apply the machine learning, we need to construct the model. So what is the model? The model is the structure. It's a structure using the library, the infrastructure of the library to orders or to set up the structure. The model could extract the knowledge, that we can understand. We can understand more clearly about the data, and it's actually it's the not perfect performance, because we can construct by another different ways, construct the model by different ways of performance. And also it's so useful in approximate the data. So after using the data, the model, we need to establish the prediction. We will investigate later. So we have to popular models in machine learning is supervised learning and unsupervised learning. What is the supervised learning? It's the kinds of data that have been labeled labels here, and label also dramatic. It look like what's this? Look like the goods, maybe the house with the price, here. We can label by the house with the consistent to the price, and the price could maybe it could call a label of the house, or the number of the house also the label. So supervised learning, that's we have the data given the labels. Sometimes we use supervised learning in classification. Yeah. Classification, that means we classify the data given. And for example, some problems in face recognition, recognize the face. They can understand the face, or optical character recognition, many with different styles, or medical diagnostics with variables. It's so famous. You see, in speech recognition, the machine can understand the voice when you put it look like Google Translate's voice, a machine translation look like the dictionary, biometrics. Another problem is credit scoring to classify the customer into they're using business as based on the incomes or savings and something like that. Another problem is they use prediction. The prediction, the label to predict the continuous, like a price of the cars, or the customers, a customer in the bank, or to navigate the car, to show the direction, the car, maybe electricity car, automatic, or kinematics of a robot. They also use the machine learning. So what next? Another second problems that's also very important in machine learning is a unsupervised learning. And these problems the data have no label. We don't have the labels, and we need to predict and to find a way to understand the label, to understand the data with no label. For example, the house with the number, attack with the number, consistent with the number, but another data we don't have the label, and we want to understand the character of the house, so it's not labeled. The problems we usually use in for unsupervised learning, maybe the linear progress in the form of y equal ws plus w0 is a kind of linear regression. Or we can use unsupervised learning in clustering to group the same characters of the data to group. We can measure the densities of the data to understand how they can focus on the points, around the points. Or we can use a dimensional reduction, that is data on the low dimensional manifold. Or we can use unsupervised learning in feature selection, that we can choose one of the feature, the character that is what we want to understand about it. We can use unsupervised learning in outlier novelty to detection, to detect the outlier and novelty. Another two machine learnings, the next machine learning, but also mentioned in this, that's not popular, is semi-supervised learning. That means the data is labeled just some points and some parts, some samples of the some samples is labeled. Another definitions in reinforcement learning in this machine learning tool, we set up the sequence of the action, the clicks, the gun. So no supervised output, and also delayed reward. It look like playing the chess or computer games or robot. Can you hear me clearly, Dr. Chu?
Yes, I can hear clearly. Yeah.
Okay, thank you. So we can proceed, right? Here is some basic related to machine learning. Sometimes we use machine learning in problems. There are many kinds of problems of machine learning, but they also based on the structure of supervised and unsupervised. The first is problems in using machine learning, maybe the binary classification. The binary classification, that's the data is labeled by maybe 1 or 0, 1 and 0, or positive and negative. For example, we want to predict the text, a sentence, or the sentence, or the words that is positive or negative. So it's labeled by 0 and 1. So we want to predict the unseen the sample, and after that we can produce the able to understand the data. In binary classification, we establish the input patterns based on the inputs, the attributes, or the instance, the data points to the attributes here that is relevant to the static. Okay, we can use machine learning in classifies the multi-class. Multi-class, that is the label maybe 1, 2, 3, 4, 5, and so on. That's a multi-class classification. So it's need more complexity, but it's also useful in statistics, which can class in classifies or look like one of cake, one heart by express the K-class classification. It's larger than 2 classes. In the nature, larger than 2 class. So we have to use another program. Many libraries support for the multi-class, but in some multi-class we use developments in statistics as usual. So how to classify to make the machine learning? After refresh or clean, the data collected is inoculant. What's inoculant? What does it mean? Okay. Because the data we collect, maybe some information is missing. It's not enough for establishing the model. So after cleaning the model, we prepare the model. We need to, after that we can prepare the model. Prepare the model, and this model we will usually divide the data set in 3D transfer. 3D transfer. The first one is training set. So it's look like a triangle, and we divide by the set. And the first one is training set. The second one is a validation set, and the third one is test set. So what is the roles of the set? And the training set we use to train for the model. To train the model, we train the model. We apply the model to train it. That we let the computer to learn the structure, of the data, certifies the hypothesis. And we usually find that we use the functions of the computer science to optimize the parameters. The parameter also important because for the big model, we need to optimize the parameter to reduce the cost or the energies of the model. And we will apply that model to optimize the algorithm. It's called learning algorithm of the computers. For example, we learn the weight of the neural net. Maybe construct with extrapolation to construct the nearest neighbor classify to construct. So the first set we use it to predict, to apply the model. And the next one is validation set. So the round of validation set in the model we use to kind of set for the model to minimize the errors and optimize the hyperparameters and the model structure. We usually done with a research. So, for example, we try to use the value of x in the set, and we can construct the lambda and satisfy the condition. And after contrast the model, you can usually construct with validation sets and training set. We let this training set for the model, and we can run the model. After that, we will use the test set to check the training, to check the model, to check the output of the model. Maybe we will perform the output of the model based on the test set to report, for reporting, for summarize, for understanding, and we could optimize the model again by update some structure, and finally we can evaluate the model based the test set. The round of validation, maybe it look like the controller for the model to make sure that the model can train the training set appropriately. Can you follow, Dr. Chung?
Yeah, I can follow, but it look like the last two sets are similar, teacher.
Sorry?
Similar. Yeah, the validation set and the test sets, they are similar.
It's confused, right?
Yeah.
The validation set, when we run the model, we establish the models for the training set. For the training set, maybe we classify in three sets like this. For the training set, the first one, so some values of the model we cannot is missing. So the validation set is the controller to complement for the model to ensure that the model is running perfectly. The test set is the prediction. It's natural after establish the model here. We will perform the output of the model. So we usually the test set. The test set may be after using the data set, we can apply for the new data. That is the function of the robot or the machine learning, that when we apply to the new data, we use the model. The model is measured by the some function that we can try by the on the test set. The test set, after applied to the test set, we will predict the output. We will show the performance, maybe how many percent how many percent the model predict for the data. So we use the test to show the performance of the model. Okay.
Yes, okay, but I have another question. For example, if we use the test set for our model, but the model work not good, what we do? What we will do in this case?
Not good. We have to
Yeah.
return. We not good. Maybe it's hard to measure the method. The problem is classify how is the model good or how is the model not good. So there are many kinds of. There are many reasons for the model. It usually show the performance that is not good. Maybe for the input, the data is not good, or some functions, some laser of the model is not good. So it's follow to, it's based on the different kinds of the models and different kinds of the function. As usual, we will update the data. It's also the way to improve the accuracy, to improve the output of the model that is not good. Or we can add the laser. We can understand that the model is established by the input laser and hidden laser is the input laser. Input. The model is usually expressed in input laser. Input laser, yeah. And hidden laser with that we cannot see. That's the function acting in machine learning. And the last is output laser. So usually we just edit or improve the hidden laser because the input cannot fix. The input has been fixed and the output have been fixed. So we just change some laser. Maybe we add some more laser in the hidden laser to get the better performance of the model.
Okay, teacher. Thank you.
Okay. So we can make the generals of the model which we select and generalize it. In machine learning problems, we can observe the data by finite, and it's not unique to determine the classification or reduction function. To find the unit solution, we and or understand something is useful, we must make the assumption because we need to there are no standard to predict or to estimate. So the bias, the difference of the learning algorithm is also needs to based on the assumptions. And we can class the class of a function by using the hypothesis what that we construct and the assumptions later in the past at the beginning of the model. So how to choose the inductive bias or particular bias? Maybe the model is hard to tell exactly, But and the goal of machine learning is not to replicate the training data, but we can predict the enzymes to generate. For the best model, we can make the complexity issue of the hypothesis with the complexity of the function to multiply the data is to understand more clearly about the data is more complex or less complex. In summary, machine learning algorithm is also consistent of three factors. Is the first one, the complexities of the hypothesis class, and second one is the amount of the training and the generalization. So we usually meet the outlier detection after the model after running the model. So the outlier is the instance that is very different. For example, we predict the data in this region in the circle, but some points or some samples of the data, maybe it run out of the out of the direction. So it's called the outlier. So many recent like the teacher asked me that's how to improve the outlier, also the errors of the model that's not good. But we need to find the reason. The exact reason is look like not easy. So the reason we usually we got is abnormal behavior or recording error or the error. So it's based on the particular problem, particular data to fix the model. How to measure the performance of the model? This is the actual the last step of the prediction, but it's so important because we can understand everything about the data by measuring. To measure, we usually use the classification error, maybe the accuracy, or to distinguish the errors by some look like a Borsity class, which confusing the Borsity class with a negative one. Okay, it's how to measure what kinds of the accuracies we usually use. For example, the function f. The function f is consistent with 1 or 2, 1 or 0. Function g is consistent with 0 or 1. So we measure the function f is consistent with the resistance of 1 or resistance with 0. Maybe 0 is negative and number 1 is positive. So the error is based on the model. The model consisting of training, which remember that is trained for the train set, and validation. We will use the model that we can estimate the output of the fx and gs with the label. we can use another method to predict, to perform the output of the model econ drop curve or area curve, as you see. As you see, or as you see, we also how to consider the model and the values that what the measure, the method, what is the way we can measure by accuracies or drop or error or IUC, or we combine together. That's based on the different kinds of the models and different kinds of the data we want to perform. So after after performance, so the performance, here is some, maybe we can skip. After predict performs the data, perform the model, the output of the model, we will understand more clearly about the data. Okay, and now we use a pattern. Let's follow me to classify the symbol model. Let's start. Let's follow me. I will type slowly and you can follow me. We use Google Collapse. Maybe we will choose the data given is fashion, maybe fashion mix. Fashion mix. Fashion mix in TensorFlow. We can use data given. What is mix? Here is the here is the data about the fashion mix. It's given by the library is TensorFlow. TensorFlow here. The structure of the models of the data is have been labeled and labeled here. And which show performance some was some kinds of the fashion that look like pullover, bass, trouser, coat, and kaput, pullover, something like that. But the man. What is the character we want to see here? It's more detail here. The data is the soft answer labeled by 0. This data and trousers labeled by 1, pullover labeled by 2, and so on, some for a tenth kinds of the data. Now we can use it for the like to construct the model. We will use this data to construct the model. First, we will I will show the name. Let's check please. Okay,
So it is are you sharing your code in your lights because I don't
the link.
yeah because I don't see anything. I don't see anything.
Huh?
Did
So,
you share your codes your client?
okay. The link, right? The code, right? Yeah.
Uh,
Can you follow? We can split, but we can split by choose Windows like this. It's quite easy to follow. Can you see, Dr. Chu?
no, not
Huh?
yet, not yet.
Not yet?
Yeah,
Oh, okay. Sorry. Maybe
yeah,
settings again.
yeah.
Oh, really?
Okay. Yeah,
Okay. Can you see?
yeah. Okay.
Okay. Oh, what? Okay. Here. We will use the data given in a TensorFlow infrastructure, TensorFlow library. The characters of the data is also labeled. So it's belong to what is the problems? What is the problems of machine learning? Do you think this is supervised or unsupervised machine learning? If we use this data, this is labeled, so it's belong to the problems is it belong to supervised learning, okay? Because the data is labeled. So we will apply, we will download the data, this data to establish the model for prediction. Okay, here is the character of the model. First of all, we will import TensorFlow as TF. Okay, we import the library of the TensorFlow to run. You can stop me if you cannot follow. Okay. We call the model. Well, we call the function. Maybe the function we will use this is called the label here is submit, I think. Okay. We can use this function this command to first submit. We submit TF. TF is the name of TensorFlow. Keras data set. That means the Keras is the library in TF, and we will call another library in Keras is data sets. That's person. Okay, first submit. Yeah, it's up here. It is. We call this library. Okay. Now we will divide the data set by four, by two set. In this problem, we skip the validation test, and we use the test set for running model. Instead, as usual, we divide the model in three sample: the training set, validation test, and test set. But in this case, we don't need to to use the validation test, we can use the test sets. So we can divide by training set. Maybe we work training X. Okay, it's starter and training labels. The labels maybe we will set trend Y. Okay. And the test set is text X and test Y. We divide the data sets by this model, for this model. Okay. First image. We will download the data, load data, this data. Okay. Before, maybe we will try to understand train X, understand the data we have downloaded by the functions steps. We will see what's the step of the training. The train set. This. Notice. Okay. The steps is consistent of 60,000 figures. Okay, with the size of the figures here. And the text. Okay, and the text set is the same size. And the text set consistent of 10,000 figure. We can solve by when we import some library that we can use to perform matplotlib pilot as POT. We import the libraries in matplotlib to perform to show the output, and we import NumPy. We use the library, the NumPy library as NP. Now we can train, we can try, we can check the first one, then Y. Okay, so this what it mean? Then what is the first member consisting of the first member of trend Y is consisting of 9 figures. So now we set the names. What is its kind name? We can use this last name here. How many names? Total is 10. Okay. Welcome. I copy it. It's consist of T-shirt, top, trouser, pullover, red coat, sandal, shirt, sneaker, bag, and then kaput. Okay. So next step, we will show some some features of the data sets. Maybe we can call PLG figure. Maybe you fish size. Size. We will fit the size of the input. Now we will show the data. So the data. So we can run for we can run in the range of maybe 20 25 the first 25 figures. Oh no, sorry. Range. Oh, not in range. Yeah. Okay. So we'll show PLG. We will show some there's a plot. Plot 5. Maybe we set the I it running by itself. IL1. So we set the axis by PLG, the axis X stick. And set the Y axis PLG. I take we set up the first the empty PLG. Maybe we add the reach. No needs. Okay, we can add the bridge. The read. Then to the functions response. F. And we will show by the IMSO figure. We will show by the function IMSO. And we show for the train set. For the train, maybe start from I running in the first 25, which in the ending function of the IMSO. 10s. Maybe we use 10s. Then as the gram, I think. The map, same map, okay. Same map, maybe we choose the function. We can check the comments of the IMSO consisting of the library. What is the library? Is some of the IMSO. Yeah. Also appear after after comma. Beyond is binary. So we set the label, the assist, the X assist, X label. It's a label in the X assist. Maybe class name. Class name here. The class names of the trained. Then Y. Then Y is a label of the level of gen x, then what we call for the I is that means it's the coordinate of the x and y. Here is the coordinates of the x and y. Okay, and the last one is POG. So here is some feature we can collect for the first sanctified figures. It's consistent of uncle boot, t-shirt, and so on. Okay, we just want to show. And now we will, before establish the model, we will clean up. But in this case, for the figures, we can normalize the data. So we set the strength x by trend. Maybe we will divide by 25. Okay, 250. Okay. We want to normalize the data. And here is dash. Let's add. We also do the same structure. After normalize the data, we will establish the model. We build the build model. We can run this. We build model. For model, we have to model predict model. There are many kinds of model we can check. Check the model compile, model pattern. We can find some structure of the model. No, it's not this. Yeah. We usually structure Keras. That's a low model here. For the model of it is some model. The models are on TensorFlow. But they can use the input with this here, the model, the structure one after structure of the model. Or we can use the function to define the new one. It's also called the model. Or the sequence. And here is some specific model. So now we use it for the model to establish the model. Now we use the functions in TF library, Keras, sequence source by this. No. So we establish the model consists of the laser. The consists of the laser. So the input laser is 7. So maybe we call the TF, Keras. We'll call the laser, the next, the first laser. Laser. Maybe we choose the laser of the input. In the library of laser, maybe many kinds of the function of the command. Maybe we choose the flatten. We choose the flatten. What is the function? We need to put some features of the flatten. Is either input in sitting input save, I think. In the input save. It's flatten here. Okay, then input save we could set for 28, for example. Okay, and the next laser we can put we call it the laser. Maybe it's what is model the laser? How to find the laser? Where is the laser? Let me guys. It's also appear here. Here is the library of the laser. The library. We can choose some of them, one of them. Dense is the function of config. Maybe we will set some variable in the library is unique. Maybe you will set 128 for the unit and activation. We need the activation. The activation function is it will ensure ensure the function the model can walk inside the model. We will choose the reloop function. Yeah. We can put some more laser based on. We can add some more visual. For example, look like we can call the function. It look like softmax function. We can use the softmax function here. Some character, some specific model, specific functions of the model. So these models are consisting of three laser of latent, and hidden laser here. Hidden laser will ask the function, will act on the function. We're using the reload or submax function here. And no comma here. There's some error when it's appear the error, maybe here. Forgot the comma. Where is the comma? Here. Okay, we establish the model. Now we want to find the models. Maybe we use model we use by summary function here, and we can see here. We can see the structure of the model consisting of the first layer here is flattened, and the parameter of the input is 784, and the hidden layer is too dense with the parameters. That means we need a little more memory and the total parameters here. So detail about the model. Okay, now we want to run the model. So we have to compile the model. So we call the function is the compile. For the compiles, what is the compiles? Yeah, the compile models consist of variable, many variable inside. Look like the optimize. The optimize we need to choose. We need to choose here optimize some consist of maybe it's a string, and the loss we have to choose the function the classifier to find the class and class way. Here's some and the matrix to measure to estimate the model. So consider of here is the character of the matrix. We compile, so now we can choose the optimizer. Can you follow? Can you follow the teacher?
Yes, I'm following. Yeah.
Okay. You can stop me anytime. We can choose the Adam. The Adam is the kind of optimizer. The Adam, yeah. You can choose it. And how about the loss? We can see the what is binary horse bar. There's the binary accuracy, but it's this side of loss here that we can press here. So many but this matter. No. That is the loss here. Where is the keras? Maybe here. That will show you the okay, many guys say. And we with some class, the classes of the class, and we do for the function. Maybe we choose spa. Many is here. Yeah. We will do this spa. This is usually. Is it available here? Spa category. Category. We use the spa categorical presence trophy. Okay. You can copy this and pass to here. And we select it. Okay, it's very cool. Here is the variable of the class. So next we will choose the matrix. What kind of the matrix? The matrix, where is the matrix? We will come back. Former page. Yeah, the matrix. It support for you the matrix. Okay, RAS matrix to measure. Let's see the function to measure to estimate the model. Yeah, the matrix. Usually we can choose accuracy. Yeah, we can choose the accuracy. Metric accuracy. Okay, and here's some basic. What is the error? Compile invalid case as compile. Spa. Invalid key argument. Clone experience distribute. Will you combine it? Is it the right? Spa. Maybe here is not capital. It's not right. Oh no, it's not capital. But the matrix missing X. Okay, we should use we could use the recon name is better. Okay. After we compile the matrix, the model, we will run the model by the command some trend. We will fit. After this, we will fit what is. Okay, we use this model here to fit it. To fit it is the function for the computer to learn inside the model. That means it's strict. It fits. We will fit trend the trend data set consisting with a trend Y. We will fit. That's the learning. This is the function learning of Amazon Y of the model. Maybe we have to establish the airport. The airport. Airports. What is the names of the airports? The airports are the route of the running, the first round. Maybe after running from the beginning of the data to the ending of the data, and they will fit the trend set and trend Y. Trend Y is the label, and trend X is the data given. The label trend S, trend Y is labeled by 0, 1, 2, 3, 4, 5, 10. And the trend S is the figures. We could set by 20. The airport is 20. If you make it bigger, you have to wait more time for the running. And of course, if you get more accuracy than the smaller one. So it will run and wait. Can you follow? Can you follow Dr. Lộc?
Yes.
Okay, now is the time machine learning. Here's the first airport 1 or 20. Okay. Okay, the model complete the learning. And after complete, can you run, Dr. Chu? Is your model
Yes,
running?
I can run. Yeah, I can run again for each walk is 10 and yeah, it touch for a long time.
Okay, okay. Don't worry. After running, we will evaluate to for the model by the text the sample we will evaluate. We will evaluate we will evaluate the we will use this model to evaluate the text and test Y. And we will set here is the name, and then of this is test loss and test accuracy. Okay, we will evaluate the model on the test sample. Okay, the accuracy is 89.17%, and the loss, that means the loss is the outlier prediction. Okay, and we want to perform, now we can perform the perform the model by the graph. So we will set the model to predict okay text set. We will set this name is y rate predict here y predict. Okay, we will predict the test and apply it for the data. Maybe we show PLG. We will show so for the first values of test S, okay, test S. Maybe we choose the first one here. Is hey, this guys, can you predict what's this name?
Uncle bot.
Okay, very good. You okay, let's check by the models. So class name, we will predict NP. We will the percent of the NP arc mass. As much of y predict of the first value. Oh, very good. Dr. Chung, very good. Okay, you can predict better than faster than the machines. Okay, and then here's the reason. We want to show, if we want to plot it, you can use the POG plot. Maybe history. We have set this model. Oh, we have not. Let's set this name. We should set this name to record it history. Maybe we set that again by 1 or 2. Set the name here. It's faster, but the plot is not very nice. So we can source LT plot, the history, con in history, the first one. History of the accuracy. Accuracies and label. We will set the name to accuracy. And for the plot, we plot for the history using in the library history for the lots label. We set the labels the lots. And we will set X X axis and Y axis as label. As label. As label for the names is airport. And Y label. Y label for accuracy, I think. Okay. You see. Okay. And we can put the legends. We can put the legends. By the the variable of lower right. Here it's a plot, but what is error? Oh, okay. Wrong. Okay. Here's the plot. It's not very nice. If you can improve the graph, we can run it again. We can run the model again. And after that, we can get the more beautiful plot. But it's so long. Yeah. Can you run it? Is there any question? Okay, is it the overall of the established model and some definition related to machine learning? I will stop.